Hello and welcome back. This is lecture 5. Till lecture 4 we have been looking at the interconnection between language areas in the brain and the language development in case of infancy, and then we took the discussion all the way to bilingualism and how early and late bilinguals may have difference in terms of their functional localization in the brain. Early bilinguals have a different functional localization as opposed to the late bilinguals, and this differentiation is not only there among bilinguals, but also among monolinguals. In case of monolinguals, the distinction is between the early words versus the late words. So, the words that are learnt early will be processed in the sensory with help to sensory motor cortex, but the words that are learnt later will have more dependence on the prefrontal cortex. Some of these studies we have already looked at, some of those findings we have discussed. Now, so age of acquisition has been discussed already. So, now we will move on to proficiency and other and few more domains. So, in case of AOA, we have seen that it plays an important role in the processing of language in case of bilinguals, but this is not the only important predictor. Another important variable here is the proficiency. So, this has been pointed out also by various other researchers looking at the aphasia data. So, in case of aphasia data, bilingual aphasia has different ways, different patterns of the aphasia itself, as well as different recovery pattern in case of the L1 and the L2. So, based on that, Petre's rule pointed out the fact that expertise in the language may have a role to play as to which language which will get affected in case of aphasia, as well as which language will be easier to recover after aphasia. Let us say after a stroke, once you have aphasia in one of the languages, then which language will you recover fast. So, Petre's rule said that expertise will be an important predictor here. So, the stronger the language with which the affected person is more familiar with will be resistant, more resistant to damage. So, in modern times, this is we use the terms proficiency and expertise, but we mean the same thing, that the stronger language means the more proficient language. In modern era, studying expertise as an important part of cognitive mechanism started with Adrian de Groot. He was a chess player himself, and his experiments, pioneering experiments also had chess, he looked at chess players and how they, what do they do, what is the cognitive mechanism that they actually utilize while while playing and while looking at a chessboard and so on. So, there are many studies. For example, one of his most important studies looked at how novice and expert players they study the chessboard. So, what do they do? How do they do things differently? Because both the masters as well as the novice players know the game of the rule of the game. They also know that looking at the chessboard at a particular stage of the game, they already know how that stage has been arrived at. So, both know the things similarly. However, the master approaches the game differently as opposed to novice. So, what happens there is what he studied. So, masters differed from the novice not only in remembering more number of chess pieces, they could more quickly also recall the gist of the position very quickly. This is one of his very important findings. So, this was one of the first research that looked at the processing differences between experts and novices in any field. Now, if they bring this idea to language, what are the domains that reflect differences in proficiency? So, proficiency has an important role in terms of how well you handle a particular scenario. So, depending on how proficient you are in playing chess, your strategies will be different. Similarly, in language also there might be some similar kind of parallel. So, that is what we are getting at. So, in case of language, what are the domains of language that reflect differences in proficiency? This was the question. So, Martha Kutas and her group looked at this question. One of the very first studies to check brain activity differences among monolingual with different proficiency level was carried out by them. It was an EEG study. The stimulus was like this. There were paired sentences and something like this. The reporter who the senator attacked discovered the error. The reporter who harshly attacked the senator discovered the error. So, these are complex sentences, and this was given. So, the probe question was, the task was to answer who discovered the error. So, in the first case the reporter who the senator attacked. So, in the first case it is the reporter. In the second sentence, the reporter who harshly attacked the senator discovered the error. So, there the answer to the question will be has a impediment of the within because of the embedded clause here. So, sentence 1 is more difficult because compared to sentence 2, since it uses a less conventional layout, thus leading to higher cognitive load. Right. Both sentences are similarly complex, but the first one is a little more because of the unconventional layout. The subjects were differentiated on the basis of verbal working memory test. So, poor performers had higher LAN effect, which is late anterior negativity. We have talked about this before. It is a negative going wave appearing between 250 to 600 milliseconds over left central electrodes. So, they found that poor performers had a higher LAN effect. Now, since both sentences were grammatically correct, the LAN effect is understood to be the to reflect the effortfulness of the processing. So, the if you need more effort, then the signal, the LAN signal will give you the idea which one was more difficult to process. So, there was no difference in processing in the second sentence, only in the first sentence. Poor comprehenders, when they discovered the verb inside the clause who the senator attacked, they showed higher LAN than good comprehenders. So, that is the finding that they reported. Also, they had a large slow positivity that continued till the end of the sentence, showing effortful processing because of the very structure of the sentence. So, many such studies have been also carried out with respect to keeping proficiency in mind and giving this kind of sentences and difficulty level, changing the difficulty level and so on. Another similar study by Neville's group found short smaller waves for both LAN and P600. We have already seen P600 before with respect to age of acquisition as well. So, among high proficient monolinguals compared to low proficient speakers, while processing sentences like Timmy can ride the horse at his farm, Timmy can ride the horse at his farm. So, the second sentence is not grammatical, and they were looking at the LAN and the P600 effects, and they found a difference between the proficiency. So, high proficient versus low proficient even within the monolinguals have different neural signatures. That is what we mean by proficiency having a neural signature. So, how do you know somebody is high proficient? This kind of signals will be seen in his case. In case of low proficiency, this kind of signal. So, that is our output variable, dependent variable. So, basic finding from all such studies is that high proficient speakers could register errors first thing, and once they have registered it, they can repair them quickly without too much cognitive load. So, the main finding is that proficiency is equals efficiency in processing. So, you are able to, the higher the proficiency, the more quickly you will be able to find out the error and then rectify the error as well. So, in case of a grammatically complex sentence or an ungrammatical sentence, your reprocessing, the reanalysis of the sentence will be similarly done. So, but the low proficiency will have a more difficulty in processing that. A 1995 study reported the case of a Bolivian woman who had migrated to US at the age of 10. At 19, she started showing signs of seizures along with naming difficulties. So, CT scan revealed a brain damage in the left temporal and parietal lobe, very critical for language. Then a surgery was done to remove the malformation of the area. So, a big area in the left hemisphere of this lady was removed. What was found out is very interesting. Before surgery, she scored 19 out of 30 in Spanish naming test. She is from Bolivia, so Spanish was her mother tongue, and she left Bolivia at the age of 10, which means the second language appeared much later in life, after 10 years. So, when she came to US, the English is the language that she will speak. So, before surgery, so the surgeries happened after 19 years. So, by that time she was speaking L2 English already for 9 years, but the first 10 years of her life she was a native speaker of Spanish. Now, so that they had a naming test done before the surgery. Before surgery, her score in L1 was pretty good, 19 out of 30. But in the second test after the surgery, the second test was carried out, and there she scored 32 in out of 60 in Spanish and 44 out of 60 in English. Now, what does it mean? This suggested that the mentioned areas of the brain affects familiar language more than the L2, which is the familiar as in the L1, because the left hemisphere part of the left hemisphere in case of the left parietal and temporal lobe was removed. So, we can safely say that that area was probably more responsible for processing the L1, the more familiar language, which is Spanish in this case. So, as a result of which after surgery her score in Spanish went down. Similarly, also there are many other studies with similar kind of finding. Another domain that has also looked at this relationship between the brain, the neural signature and L2 among bilinguals is the domain of control mechanisms. So, control mechanisms, when you are a bilingual or a multilingual, you have let us say you are a high proficient bilingual or multilingual, then there is a control mechanism that we need to put in place in order for us to control which language to use and which language not to use. For example, I am a multilingual. So, right now I am using my L3, English is let us say my L3. So, now I have to subdue my L1 and L2 and then other languages as well. So, that every bilingual exercises a control mechanism in order to have to decide which language to use and which not to use. So, this is what comes under the domain of executive control mechanism. Executive control has these 4 domains, 4 important parts. So, inhibition, monitoring, selective attention and flexibility. Flexibility also is called, flexibility includes updating information. So, depending on the environmental cue, we update our information structure and as well as a result of which our reaction, behavioral output as well. So, inhibition is an important part of executive control mechanism. Now, separate brain regions are responsible for these activities. So, the question is, do monolinguals and bilinguals use the same brain areas for this function or not? So, if you are a bilingual, do you use the same areas that the monolingual uses for these purposes? So, in some studies involving these two groups, similar activation patterns were visible. So, the areas that we are mostly interested in for this kind of studies is ACC, most importantly ACC, anterior cingulate cortex. This region is responsible for impulse control and decision making among other things. In a combined Stroop task fMRI task, both monolingual and bilingual groups were found to activate the same region. Now, what is a Stroop task? Stroop task will be, for example, the classical Stroop task is something like this. Let us say I write the word black. Now, the task is to say let me give you an example, a classic example of Stroop task. So, let us say this is the task, this is the Stroop task. The participants are asked to look at the words and mention the color of the ink, not the color that is mentioned there. Now, Stroop task, what Stroop task does is, Stroop task takes your inhibitory control mechanisms. The goal here is to suppress the automatic reaction. Automatic reaction is, it is a well established fact in literature that when you see something in writing, our first reaction, which is almost involuntary, which is automatic processing, is to read it as it is. Now, the task here is to suppress that, inhibit that reaction, that involuntary reaction, rather focus on the color of the ink. Now, in the first case, this is color of the ink is black, sorry, the word is black, the color of the ink is red. In the second case, the word black is written in black ink. Now, this is obviously the more difficult task, this is the easy task. So, this is called the Stroop effect. So, when you have stimuli like this, you will have a higher Stroop effect. Stroop effect matlab you will have the reaction time will be higher. So, you will take more time to say the name of the ink. As you saw just now, I have also made a same mistake. Most participants will make some mistakes. So, error rate will be higher in the first case, error rate will be lower in the next in the second case, and also in case of the correct answers, the reaction time will be higher. So, this is classic Stroop task. In this particular experiment, they use Stroop task and fMRI together. So, as the participant was taking part in the Stroop task, fMRI was also going on with on their brain. So, both monolinguals and bilinguals bilingual groups were found to activate the same region, which is SSC. Why SSC? Because SSC is responsible for impulse control. So, you have to control responding black in the first case. Similarly, in a different study using Simon task and caudate nucleus was activated for both groups, monolingual and bilingual. Simon task is yet another task that checks impulse control, executive control and so on. Similarly, another study in 2015 compared the gray and white matter volume in lifelong monolinguals and bilinguals. And they found something very interesting, that bilinguals showed more frontal lobe white matter. So, if for a bilingual, lifelong bilingual, the chances of having more white matter in the frontal lobe is higher. So, that is what they found. Also, monolinguals showed decreased white matter in the temporal lobes, but not bilinguals. So, bilinguals did not show any decrease in the white matter in the temporal lobes, and they showed increase of white matter in the frontal lobe. So, this was a serious difference between the bilingual and the monolingual participants in this study. So, when they administered Stroop task on them, Stroop task we just discussed, white matter volume correlated with task performance. So, depending on the higher the white matter volume, the better the performance of the participants, that is what they found. Now, these areas of the brain are responsible for executive control. So, those areas of the brain which are responsible for executive control seem to have higher gray matter, and those people also did better in the task. Hence, the argument is that bilingualism alters brain physiology. As I started this lecture with, that language actually interacts with the structure of the brain. Not only we are not only talking about the functional localization, but language use, bilingualism specifically has contributes to the structural changes in the brain. Some data also have come from the resting state studies. For resting state, as in when the participants are not doing anything, they are simply resting, and the brain just the studies, the probes will look at how the brain functions during that time. So, research in this domain tries to see the functional connectivity inherent in key areas when there is no explicit task at hand. So, how the connections have been, how the functional connectivity are there even when they are not doing it, doing any kind of action. So, the key question was, does experience induced neuroplasticity modulate functional connectivity in bilinguals or not? Seems that this is the case. So, the results suggest the same. So, what the hypothesis was found to be verified by the data. So, for bilinguals, the functional connectivity will be different compared to the monolinguals. In an interesting study, again a more recent study 2017, ACC sulcation pattern was studied in monolinguals and bilinguals. The method used is called brain morphometric analysis. The participants also performed a flanker task for executive control measures. All of these tasks are executive control measures, Simon, flanker and so on. The main question was if sulcation pattern was related to performance in the task. So, what they found out was SSC sulcation variation was found to correlate with the task performance. bilinguals had with more sulcal variation who did better than monolinguals. A usual finding that bilinguals will typically do better than monolinguals in most tasks that requires executive control. So, based on this finding, the authors proposed that early neurodevelopmental mechanisms depend on environment, which in turn can affect cognitive efficiency. So, these and other findings have led to what is the most debated topic of bilingual advantage, but that is for another day. L2 acquisition also has, we have just seen that bilinguals seem to have more white matter in certain areas. So, that takes us to a domain which talks about bilingualism, that is constant use of two languages, has an effect on the very anatomy of the brain itself. So, that kind of in real term literally it messes with your head in a good way. So, one influential study in 2021 by Liu et al. Reported that gray matter volume decreased in the left anterior cingulate cortex and right inferior frontal gyrus after L2 learning for 1 year. This study was carried out on Chinese speakers of English. So, English was the second language, and just after 1 year of using L2, brain anatomical changes in the brain was found out, and the gray matter volume decrease was seen. So, gray matter, white matter, they change as depending on how long you have been speaking your L2. So, these changes are connected to language control abilities in bilingual. As I was just mentioning, when you speak more than one language, automatically the inhibitory control process is activated. So, there has to be an control mechanism in order for it to be able to effectively use one language or the other in a given scenario. So, control mechanism automatically appears when you speak more than one language, and these changes with respect to gray matter and white matter are connected to executive control mechanisms. So, as a result of which this is a very common finding among bilinguals, but this study was among the very rare studies that actually looked at it from a longitudinal study. So, they checked the participants before and they checked them after 1 year, and they actually saw a gradual increase. So, findings such as these point towards a dynamic structural adaptation of brain regions in relation to L2 acquisition. So, based on these findings, there have been models that have been proposed, models of brain adaptation due to bilingualism. These models suggest the structural brain adaptations are dynamic and can be expressed as cycles of local tissue increase and decrease depending on the duration of the L2 learning. So, we have already seen that in some cases the white matter will increase, in some other areas white matter will decrease, some cases the gray matter will increase, and so on. So, based on these findings, there are few theories that have been proposed. We will discuss only two models. These models are based on the idea that this is a dynamic kind of a relationship, depending on how long you have been speaking the L2, we will see certain kinds of changes, and those changes are connected to the control mechanism that we utilize. So, one of the models, this is bilingual anterior to posterior and subcortical shift model proposed by Listock and others in 2017. As per this model, the duration of exposure to L2 has an impact on the dependence on ACC for its processing. If you have noticed, in all these studies, many of the researchers actually focused on the region of ACC and how it gets activated by bilinguals, monolinguals, early versus late, and so on. So, ACC dependence on ACC has a direct correlation with respect to the duration of the L2 exposure. That is what this model has incorporated into. As the learning duration goes higher, reliance on frontal cortical region decreases. So, in the beginning when you are speaking an L2 and you are not very good at it, your proficiency is not very good. So, you need a lot of effort. So, effortful processing will be seen in the prefrontal cortex. As the exposure, the time of the exposure goes higher. So, let us say from 1 year to 2 to 10 years, the dependence on the ACC will decrease, because now you do not need, now the process is not anymore effortful. hence the decrease, and increase on subcortical regions like left caudate and the posterior regions like the occipital lobes. So, there will be a shift from the ACC to the other regions including subcortical regions and the posterior cortical regions like the occipital lobe. Another model that has actually built up on the previous model, this is proposed in 2020. This takes the idea a little bit forward and they propose different 3 different stages within this. So, the previous model says that there is a shift from the dependence on ACC to the subcortical regions. This model says that there are actually stages through which this shift happens. They call it the initial stage, then the consolidation stage and the efficiency stage. So, initial stage is where you have the most dependence on the ACC, and then over a period of time when they are efficient users of the language, that is the last stage, that is the third stage. So, more recent findings suggest that bilingual experience also has direct implication for changes in the subcortical regions. So, we started with the cortical regions. Initially, we talked about the Broca's area, Wernicke's area and the 3 major visual, motor and sensory cortex. Now, we have come all the way to the subcortical regions as well. Not only we are talking about subcortical regions being responsible for language acquisition and processing, but now we are saying that bilingualism, the length of bilingual experience has the impact on the even on the changes in the subcortical region. So, we have come a long way. Researchers have the findings, the developments of research in this domain has really gone through a lot of changes, paradigmatic shifts, and now we know that bilingual also has a non-linear effect on the basal ganglia and thalamus. So, not only the cortical region, but also various subcortical regions including all of these. So, thalamus and the basal ganglia and so on. These are more recent findings. This is a very influential paper from 2023 that has looked at this. So, this is not a linear kind of an effect, there is a non-linear effect. So, this is not only dynamic, but also it is non-linear, the impact is non-linear. So, to sum up, in this module we looked at the relationship between language acquisition and the brain structure. Some of the cases, mostly in case of early language acquisition of L1, there are near simultaneous developments in language as well as brain maturations. In case of L2, some changes are seen in the cause effect relationship between these two. So, as language develops, as your proficiency develops in L2 and as also as the duration of exposure to L2 goes up, there are certain changes, actually some causal impact on the brain structure itself. So, this is a very this is an evolving field. We are still getting very exciting results from different groups that are looking at it. So, the field is getting richer every day, but we have to stop somewhere. So, this is where we wrap up this module. Thank you very much.